This is section 2.1, part 5. Example 5. Suppose you're given the supply and demand functions of cell phones, and we need to find the equilibrium price. If you recall, we said that equilibrium is where the supply and the demand are equal. So in this case, all we have to do is set the supply equal to the demand function and solve for P. If you move a few things around, you should get that P is equal to 100. I did ask you to interpret your answer, and I'm going to ask you the same thing on the test because I want to make sure you know what the P equals 100 means. And all that means is that when supply and demand are equal, the price per cell phone is 100. So I think here people are pretty happy because the supplier doesn't have that much product left over, doesn't have anything because they're selling it all. And the person who's buying, the consumer, is buying without having to get on a wait list to receive a cell phone. Next, it says, find the equilibrium quantity and interpret your answer. Note that since supply equals demand at the equilibrium, you can plug in P equals 100 into either the supply function or the demand function, and you will get the same exact answer. I'm going to choose D of P randomly. Maybe you want to try it with the supply function and see if you get the same thing. But I'm going to plug it into my demand function. And if I put that in the calculator, we get that D of 100 is equal to 2100. And again, what does this mean? Interpret your answer. Well, this means that when the company supplies, happy birthday, supplies and sells 2100 cell phones, the price is $100 per cell phone. Part C. Determine the prices for which quantity supplied is greater than quantity demand. When you're doing this, just be careful and make sure you're writing the correct symbols for each of these. So quantity supplied, that's S of P, and quantity demand, that's D of P, and we're using an inequality here, greater than. All we have to do is set up the inequality for this problem and then solve the problem. S of P was 30P minus 900 and D of P was negative 7.5P plus 2850. If we move things around, you should get that P is greater than 100. And again, interpret your answer. What does this mean? Well, this means that if the company charges more than $100 per cell phone, quantity supplied will exceed quantity demand. What does that mean? Well, that means that the supplier is going to have more phones in stock and the demand is not going to be as high, which makes sense because if the phones cost more, less people are going to want to buy them. Now we're ready to graph the supply and demand function, and notice that they are linear equations. D of P is equal, what was D of P? Negative 7.5 P plus 2850. Notice here we have the y-intercept, so we can start there. I'm going to start at 0.2850 since we have the y-intercept. So it looks like 2850 is maybe here. That would be 0.2850. Oops, wrote the comma in the wrong place. And I also know that the supply and the demand are equal at P 100. So I'm actually going to use that fact. So I'm going to go back up here and I'm going to highlight it so you know where I'm going. So I know that D of 100 is 2100. And again, at that point, the supply and the demand are equal. So we can actually use that point for both of these. So one of the points we have is 100 and then 2100. So let's go ahead and plot that point. So 100, maybe about here. And because this is linear, I can just go ahead and draw a line. I don't have to keep plotting more points. So this here is D of P. Notice too that I'm only plotting positives, and that's because price cannot be negative. And then we have our supply function, which was 30P minus 900. In this case, I won't be using the y-intercept just because the y-intercept is 0, negative 900, and I'm not even plotting negative values. I will use, though, the fact that I know that slope is 30 or 30 over 1. So the rise is 30 and the run is 1. And I'm also actually going to start at the equilibrium point. So I'm starting here at the equilibrium point, and we can rise 30 and go up over 1. So the next point is going to be 2030. And I don't know, it's actually really close. Probably closer than that. So that point, since we rise up 30, that point there is, and we go over 1, that point there is 101. 2030. And you know, one good thing to find here, because I don't want to use the y-intercept, is the x-intercept. So, and that's pretty easy to find. We know that the x-intercept is when y is 0. In this case, our y is s of p. So I'm going to set this equation equal to 0 so I can actually find, that's probably a better way to do it. So here P, let's see, we move over 900, and then 900 divided by 30 is 30. So we have 30, 0. That's a better way to graph this instead of using the slope. So I'm going to plot 30, 0, which is here. And then use that. So let's get rid of this one. This one I'm not going to use. Okay, and then this is the supply function. And there you have it. And I'm going to just label my equilibrium point. That was 2100. 2100. And there you have it, our graph. And finally, what will eventually happen to the price of the cell phones if the quantity supplied is smaller than the quantity demand? What do you think? Well, since more people want to buy cell phones, the price will decrease, which means not everyone might get a cell phone since the supply is smaller than the quantity demanded. And you can see that by the graph. Now, do you think that this is true for every scenario? Can you think of an example that if the demand is high, the price will also be higher, or vice versa. So this is not true for every scenario. So yes, think of something, put it in the discussion board if you like. And I guess I will write here so you have the answer. Since more people want to buy, and this answer you can see on the graph, cell phones, the price will decrease. And again, this is not always the case. It's just for this specific problem, which means not everyone might get it. So not everyone's going to get a cell phone because everybody wants them since they're cheaper. Not everyone might get a cell phone since the supply or the phones produced is smaller than the demand, or how many phones the consumer is buying. Number of phones consumer is buying. And that concludes section 2.1.